Greetings, friends of chemistry. Martin and I are recording a video for the practice problems for Module 8.
Indeed, we are.
Martin, will you please read us number 1?
These can be found on page 284.
284, thank you.
Draw the Lewis structures for the following atoms. A, Ge. Yeah, well, she's already got them
Te and Ba. So Ge, let's look at the periodic chart at the front of the textbook. Remember, in a test, you would be able to look at the periodic chart at the front of your textbook. We always will allow you to look at that. You don't have to have the whole periodic chart memorized. Please find Ge on it, Martin.
Okay. So it's number 32 in column 4A.
4A. So the Lewis structure is the electron dot diagram, right? And it tells us what, not the whole structure of electrons, but rather the what? The valence electrons. So being in column 4A has a meaning. It means that it will actually have four valence electrons. So helpful. So the way we draw them is going to be, write the symbol Ge, and we start to the right, and then we go to the bottom, the left, and then the top. That's 4 electrons. So that's what Ge is going to look like. Martin, where is Te? Can you find it?
Okay, yeah.
I think the first was germanium or something, and this is tellurium or something.
43 and column 7B.
7B. So it's got 7 you sure? Te?
Yeah.
That's Tc, darling.
They look identical.
So true. Here it is in column 6A, number 52. So, Te in column 6A. So it has 6 valence electrons. Okay, so we're going to draw the Te symbol. And I start 1, 2, 3, 4, 5, 6. So it's going to look like that.
See.
Okay. How about barium, Ba?
That's 56 in 2A.
2A. So it has only 2 valence electrons. It's going to have 1 to the right and 1 beneath. Okay. Any questions about that, Martin?
No.
Okay, let's look at number 2. Sorry.
Okay, number 2 is give the chemical formulas for the following molecules.
Okay. Is there an A?
Of course. Aluminum sulfide.
And that's written out?
Yeah.
Aluminum. The rest of the world calls it aluminium. Just so you know. It's the same thing. Next.
Cesium nitride.
And next?
Magnesium oxide.
Okay.
And chromium 3 oxide.
Chromium 3 oxide, you said?
Yeah.
Mm-hmm. Did I get them right?
Yeah.
Excellent. Okay. So aluminum sulfide. Talking about our nomenclature, the key to the names. That's the first thing we have to look at with these, right? Aluminum sulfide. What kind of a substance is aluminum?
It's a metal.
It is. Okay. So we're going to be talking about what kind of a compound, a molecule. This is a. Or should I say an? It's an ionic.
Yes.
Right? So it's an ionic compound. Okay. So let's find aluminum first.
Well.
Here it is, number 13. Okay. So how do we figure this out? So these are ions, right? So we've got positive and negative ions that are going to be working together, right?
Yeah.
So how do they come together? Being in group 3A tells us something about it. What does it tell us?
That there's 3 valence electrons.
Yes. So group 3A, all these, everything other than boron, which is a nonmetal, all the others in this column, this is found on page 255, all the others in this column will develop a 3+ charge because they have 3 valence electrons to lose. So we're going to have Al 3+, right? Okay. How about sulfur?
The symbol for that is S.
So sulfur, S, is number 16. So here it is under oxygen. It's in column 6A. So what does that mean?
It means it's got 6 valence electrons.
So it's going to have a charge of 2-.
Okay.
Okay. Does that make sense?
Yeah.
Okay, again on 255, in case you're having any questions. Group 6A has mostly nonmetals, which will develop a 2- charge in ionic compounds. And you don't have to worry about the metals because we're not going to be dealing with that kind of thing in this class. In this class, we're going to be dealing with, it's really basic chemistry. It's solid chemistry, it's good chemistry, but we're not going to be doing anything too super complicated. Okay, so they say ignore the signs and switch the numbers, right, to write your ionic compound. So forget these signs. It's going to be Al2, right? Switch the numbers, S3. This is the quick way to figure out your ionic compounds. If you look at the 2 ions and you see the charge, okay, the way math works means that you can do this. So it's really, if you want to work it out, the book shows you how to do it. I'm not going to show you how to do it right now unless somebody wants me to. I don't think Martin needs it. If you watching this video want to see more, please contact me. I can show you how to do this. But you ignore the signs and switch, what is it? How do they put it? Ignore the signs and switch the numbers. So you don't have to have a positive and a negative in your ionic compound. It's Al2S3. Okay, cesium nitride. Let's look at the periodic table. Cesium is over here, number 55, CS. Okay, and what is it, Martin? What column is it in?
It's in 1A.
Okay, so it's 55. In 1A. What's that?
Number 55.
Right. So in column 1A, it's going to have a charge of 1+. Okay? I'm going to write 1+ next to it. Or you could just put plus. So I'm going to put 1 for the handiness of it. Nitride, that's nitrogen, right? Yep. So where do you find that? N. There it is, number 7. What column is that?
That's in 5A, number 7.
Okay, and how do we deal with that? Let's check again 255 to confirm that we're doing it correctly. You said 7?
Yeah.
Group 7A has nonmetals which develop a 1- charge in ionic compounds. So there's going to be 1-. So now we ignore the signs and switch the numbers. Oh, that's going to be easy. There's just 1. So the subscript 1 you don't even have to write. So it's CSN will be our wait a minute.
Symbol?
No, you said it was in 7A. It's not in 7A. I beg your pardon.
I said 1.
It's in 5A. I lied. So it's in 5A. Excuse me. So nitrogen is in 5A. And 5A means it has a 3 negative. So we ignore the signs and switch the numbers. We end up with CS3N. Sorry about that. I misheard you. You didn't say it wrong. I misheard you. Okay. We can go back and check the video just in case there's any question about it. I'm sure someone can set us right.
Let's look at the record.
Magnesium. You can make your argument in the comments. All right. Martin, what's the magnesium now? Let's look at that. Magnesium oxide. So it's helpful to find it here first.
There it is. Column 2A.
Number 12.
12.
Okay, so column 2A. How do we deal with column 2A? It's a metal, right? So it's going to have a plus charge. And what's it going to have? Plus
2.
Plus 2. 2 plus. So we're going to write Mg2 plus. How about the oxygen? Oxide. It's over there in column
6A.
6A. So it's going to have a 2 minus, right?
So that's easy. Mg2O2.
Right. But since the numbers are the same, we're going to ignore them. It's just going to be MgO.
Okay.
Let me just confirm something. We're being asked, to give the chemical formula. Good. Okay.
Chromium is number 27 on column 24 on column 6B.
Are you sure?
Yeah. Doubting me.
Okay.
Do you
All right.
doubt my memory?
But we're not just given chromium. We're given chromium
Oxide.
No, we were told chromium 3 oxide, right?
Right.
So because we're told, sorry, I should have written it like this. Because we're told it's chromium 3, that tells us something. We can't tell looking at column 6B what it's going to be. We don't know. We don't have enough science to know that, right? We're not going to be covering how to figure that out in this class. But we're told that it's chromium 3. So that tells us that we have Cr 3 plus. Okay? That's the one we're talking about. All right? With oxygen being in group 6A, it's, as we saw in the previous one, O2 negative. Okay, so now we're going to ignore the signs and switch the numbers, which leads us to Cr2O3. Okay?
Mm-hmm.
In general, the reason we didn't have to have Mg2O2 is because it's probably going to be the simplest ratio. Okay? That's it for questions 1 and 2, and we'll come back with a separate video for further ones. Thank you.